My name is Pauline Kamermans and I'm a senior researcher at Wageningen Marine Research and the Marine Animal Ecology Group of Wageningen University.
My name is Remment Hofstede. I'm a marine ecologist and I work at the marine contractor Van Oort in the Department of Environmental Engineering. Next to that, I also undertake a PhD research at Delft University of Technology and the Department of Civil Engineering, and there I specifically look at what methods we can invent to support this development of oyster reefs in the North Sea.
The native oyster used to occur in the North Sea over large areas in the 19th century, but we have lost those oysters due to overfishing and diseases. And these oyster beds played an important role in the North Sea ecosystem because the shells of the oysters provided substrate on which other organisms could live, and in that way it enhances the biodiversity of the North Sea area. And that is the reason why we would like to restore the flat oyster in the North Sea to have more hard substrate to enhance biodiversity. A native oyster is a different species compared to other shellfish species like the mussels and the Pacific oyster, because they reproduce in a slightly different way. The mussels and the Pacific oyster, they produce sperm, the males produce sperm and the females eggs, and the two find each other in the water column, and that becomes a larvae, and then the larvae spends around 14 days in the water. And after that it looks for a place to settle on. But the flat oyster has is a breeding species. That means that the female oyster keeps its eggs in the shell, in the mantle cavity is what we call that. And there the eggs are fertilized and they spend the first 10 days in the shell before they are released. And then the period in the water column is much shorter compared to the other species. That also means that the distance that can be traveled with the current is also much shorter. It is important to actively restore oysters in the North Sea because there are hardly any oysters present in the North Sea at the moment. Sometimes you find one or two on a shipwreck, but that is not enough to start a new population. So you need to bring adults to the North Sea so that they can produce larvae, but you also need to introduce substrate that the larvae can settle on.
The basics of starting an oyster reef are of course that the environmental conditions are suitable. That means a temperature range and a salinity range that is within the limits of the needs for oysters. And next to that, the seabed needs to be relatively undisturbed, and also you need to have a substrate on which oyster larvae can settle. Well, all these factors, they are combined in the offshore wind farms. The conditions in the North Sea we know are good for oysters. The wind farms have an undisturbed seabed because no activities are allowed at the seabed after construction at least. And also within the wind farm, most of the wind turbines have a layer of rock material at the base of the foundation, and that to prevent the seabed from erosion. And that rock material is very suitable for oysters to settle upon and to start growing into an oyster reef.
When you think about the source of oysters for restoration in the North Sea, there are a few things to consider. First of all, the oysters need to be disease-free. Secondly, they need to be available. And thirdly, the genetic composition needs to be in such a way that the population will survive in the longer terms. So the flat oyster suffers from a disease which is called bonemia. It's a parasite, and it affects the oyster in such a way that it might die around the age of 2. Since there are no oysters in the North Sea, or hardly any oysters in the North Sea, we don't want to introduce that disease. So the source of oysters needs to be disease-free. And there are not many locations in Europe where you can find oysters without the disease. We have oysters in the Netherlands, in Lake Grevelingen, we have a natural population, but there the disease is occurring also, so that is not a suitable location. But we also have areas in Norway and in Ireland where the disease is not occurring. Then when it comes to availability, the adult oysters are relatively scarce. So another way of getting oysters to start an oyster reef is hatchery production. That means you take adults from the sea into a controlled condition where you reproduce them, and then you harvest the larvae and they settle on substrate, and then you have what we call spat on shell. You can let them settle on shell, and spat on shell is also a good source to start a new oyster reef. Hatchery production does have a drawback though, because you take a limited number of adults, you reduce the genetic composition of the product, and there is a risk of inbreeding. So when you start producing oysters in a hatchery, you need to take into account that the genetic composition is diverse enough to avoid inbreeding.
The offshore wind farms that we construct, they are remotely located from the natural oyster reefs, and we know that the oyster larvae cannot reach the wind farms by themselves. So if we want to introduce or induce oyster reefs in wind farms, we actively need to bring in the oysters into the wind farms. And there are several methods for doing that. One is, for example, that you settle oyster spat on shell material and you distribute the shell material in the wind farm, preferably on a layer of other shell material which we call culch. You can also do that with adult oysters. You can distribute them loosely on the seabed. And a third method is actually to bring in broodstock, these adult oysters, when they are fixed on artificial structures. And the advantage of that is that you can place those structures, these broodstock structures, for a certain time in the wind farm, and at the wind farm they can produce larvae. The larvae can settle around these artificial structures, and after a couple of years you can relocate these structures to another location in the wind farm where they can do the same thing.
In the ReViFE projects we are testing different materials to find out which are preferred by the oyster larvae. So for example, what I have here is a piece of granite, and this is a piece of marble, and a piece of 3D printed sandstone with a rough side and a smooth side. And we have tested those different substrates and some other substrates in the field, but we also looked at them in the laboratory at Wageningen University, where we have a system to track the movement of individual larvae to find out which of the different substrates that we present to them, which of them they prefer best. And we also tested a paste developed by Bureau Waardenburg, and that seems to attract larvae to the substrate, so it seems to work quite well.
For initiating oyster reefs, you can support them at different levels, at different scales. At the macro scale, which is kind of the entire Noordzee, you need to overcome this connectivity issue to bring in the oysters actively in a wind farm. At a macro scale, you can look at the entire wind farm, where to support them, especially use as much surface area as possible for initiating oyster reefs, for example by making the seabed suitable by providing layers of shell material on the seabed. At the meso scale, you can do something with the scour protection, which is the rock layer at the base of the foundation of these wind turbines. Well, generally these layers are kind of pancake-shaped structures with a layer of very small-sized rock topped with a little bit of a larger rock material, so-called armor layer. And you can change the shape of these pancake-shaped structures, making it more organic, going into the height and also into the width. And by doing that and changing the shape, you provide areas where the oysters can shelter or find shelter and a settlement area. And the final scale is the micro scale, which is changing the type of material that you use. For example, the calcareous rock is better than a conventional rock material for oyster settlement, and also you can change a bit the texture of the material that you use. The more rugosity it has, the easier it is for larvae to settle upon. When we take these interventions for making our marine infrastructure more suitable for oysters, we can also consider suitability for other types of marine life. For example, if you look at the scour protection, if you change the size of the rock that you use and also the grading width, for example narrowing down the grading width, which means only using a certain type of size of rock, you create cavities within these rocks in which other animals can shelter. So what we always do when we think about solutions for enhancing nature in these wind farms, we don't consider only the oysters, but we also consider what can be done to make it more beneficial for other types of marine life.
For oyster restoration to become a success, there are some bottlenecks that need to be solved. For example, the hatchery production is quite difficult for the flat oyster. There are a lot of unexplained mortalities. And to solve this problem, we have two projects working on this. One is the ReViFES project, where we specifically look at the diet for the larvae to see if that changing the diet can increase the survival. But we also have the Koopon project, in which the rich Noordzee is a partner, where we have the hatchery producers and the researchers working together on a protocol that will increase the survival of the larvae and the settlement rate on the substrate as well.
We know that the Dutch part of the North Sea was covered with 20% of oyster reefs, and if that would be our objective to really restore that vast area, we need to combine our forces. We know from many little projects what can be done. For example, we know that oysters survive, we know where to get them from, we know how to rear them as pet and outplace them in the field, both as pet and also as broodstock. But all these exercises are done on a very relatively small scale, and that's not sufficient to reach that vast amount of oyster reef that we really strive to restore.
It's important to consider all the lessons learned from the different pilots. We have the Borken Reef pilot in the north of the Dutch part of the North Sea, where adult oysters were placed on the sea bottom. And then we have the Winor pilot in Gemini wind farm, not so far from there, where we have shells on the bottom, and on top of that adult oysters and spattered shell is placed. We have the Luchte Duinen pilot, where the sand waves are quite high, so there you need to look for another way of placing oysters. And then we have the Borsele wind farm pilot, where the oysters are placed in a broodstock structures. So every pilot is testing a different method in a different environment, and if we can take the best solutions for the different environments, we can probably scale up. But we also need to learn from the pilots that are taking place in other countries. Like in Germany they are restoring oysters, but also in Belgium. And luckily we have this organization, the Native Oyster Restoration Alliance, where all these different organizations are communicating with each other. So I'm quite positive about the future.